The following webinar is presented by the E-Extension Farm Energy Community of Practice at extension.org and the University of Nebraska Lincoln Extension.
Welcome everyone. Hello, my name is John Hay from the University of Nebraska Lincoln Extension, and today's Bioenergy Friday web seminar is going to cover ethanol and small engines. Our speaker today is Ed Brokish from Kansas State University. Ed is a professional engineer there at Kansas State in the Ag and Biological Systems Engineering Department, and Ed does some teaching in the department and a little bit of extension work. And some of that extension work is what we're going to see today, looking at ethanol issues and bioenergy issues. And so one question that's come up over and over and over in my discussions with people about ethanol is issues related to how ethanol affects the engine. People will say, well, ethanol burns hotter, or they'll say ethanol ruins my engine. And so we're going to answer some of those today, in particular related to small engines. So welcome, Ed, and I'll turn it over to you.
Okay, thanks, John. Thanks for the wonderful introduction, and thank you all for attending the presentation today, and hope you find something of use to you. Why this topic is, it comes back to the renewable fuel standards and some mandates we've got out there that we want to be able to use 36 billion gallons a year by 2022, and the statute I looked the other day says we should be using about 15 billion gallons of ethanol in 2014. And other speakers on this series and other literature talks about the blend wall, and that the fact that if we don't do something different, that we just cannot get this much ethanol consumed in a year's time. And so we had the idea of E15 fuels becoming available, e-diesels, and some things like that to find a greater outlet for the fuel. And with that comes some concern is how does that impact some of the older engines that we have out there and the small non-road engines, which is what we're going to talk about today. This topic, I wrote a paper based on the small non-road engines, and that led me to think about the legacy engines, and that's if you go out on the John's UNL Crop Watch Bioenergy page, there is a webinar that I did last August available that is part of this, and this webinar today and that webinar that day kind of tie together and covering this topic, and it is still kind of a higher level view of it. It's not a down and tremendously detailed view of it, but we do cover a lot of topics. The other thing about this topic today is we're going to talk about the small engines in particular because, one, ethanol does impact them differently than a regular fuel. But the other thing is that there's a lot of engines coming out of storage as we speak today. The lawnmowers, they've all been put away for the winter, and now they're coming out to be utilized. And so this is kind of a timely topic for that. And we're going to talk about some of the characteristics of those small engines as they come out of storage that has nothing to do with ethanol. So there's other topics that we're covering today besides just the ethanol discussion. So here's kind of our roadmap. We'll talk about some definitions. We'll talk a little bit about the small non-road engine characteristics, and I will henceforth refer to them just as small engines. We'll talk a little bit about ethanol, some compatibility, storage, a little bit about the combustion of ethanol and small non-road engine ethanol operation, some emissions, a few takeaways, and then I'll take some questions. So definitions, octane, you go to your filling station and there's a note there that says octane of this fuel is 87, 89, 93, or some other number, and there's a lot of misconception that has energy content to it. It isn't. All it is the resistance of that fuel to knock or ping in your engine. The energy content is something different. the energy content of 87 octane and 93 octane, while may be different in a little amount, it isn't that great. It's more to do, the octane has to do with the ability of that fuel to not knock or ping in the engine. Energy content, it's again the amount of energy that's within the fuel, and that you do not see on your gas pump. The other thing that we'll talk a little bit about is an air-fuel ratio, and that is always on a mass ratio of combustion air to fuel to get complete combustion. We're looking at the chemical equation where you've got fuel and air, and what's the ratio to get complete combustion of the fuel. The other topic or definition is vapor lock, and that's the pressurization of the intake manifold or carburetor, preventing flow through or fuel flow through the fuel system of the engine. So, small on-road engine definition. Generally, we're defining it as a 25 horsepower or less, used in a household or light commercial application, 2 or 4 stroke engines, couple cylinders, or not, or just a single cylinder. And some examples of that are shown down below here. And as you look over to the right-hand corner, there's a picture of a small engine. As you go through, there's a small sampling of engines that are out there. And when you start thinking about small engines, there are a huge number of different varieties and different uses of these little engines. Now, some of the other characteristics of a small engine are they're simple. They're down and dirty simple. They're used seasonably. You don't use them every day of the year. They're task-oriented, meaning that like you don't use your lawnmower in December and you don't use your snowblower in June or July. They have shorter duty cycles, meaning that they're not designed to run every day of the year. They're designed to run for an hour here, an hour there. And then the other thing that I would like to point out is quite often the small engines are used in very dirty environments. And the lawnmower here at the right you can see is kind of dirty and is a good example of the sort of environment that a small engine is utilized in. Talk a little bit about ethanol. What is it? Well, it's a compound made by fermenting grains, or we can also do it from grasses. The chemical composition is showing here, and what you usually find it at the filling station means that it's denatured, and that is that you can't drink it. Some of us can go and find some of this same material at a store, and it is drinkable, but what we're going to talk about today is intended as a fuel and is generally always denatured. It's made from corn grain, sorghum, sugarcane. We also are looking at it from sweetgrass and corn stover, as well as wheat straw as being a substrate to make this fuel. It's been around as a fuel for a long time. Henry Ford advocated it for it over 100 years ago. It was used by both sides during World War II. And in the late 70s, between World War II and the 70s, it kind of went away as a fuel. But then in the late 70s, with the energy crunch of the early and late 70s, then it came back as a fuel. And in the mid-80s, because of that, when it came back in the late 70s, there was a lot of problems, and I can attest to having some of those problems with a vehicle of mine. There's some quality problems with the fuel at that time, and then the engines just didn't have the compatibility for the fuel. And so then by the mid-80s, the equipment manufacturers, the engine manufacturers for automotive uses, they realized that ethanol was going to be coming as a fuel or be around, and so they started making the engines tolerant to the fuel. And then Also, at the same time, there's a lot going on with regard to air quality and how by adding an oxygenate to the fuel, we could improve our air quality. And MTBE came along, and we decided that we needed to replace that because it was turned out to be a groundwater contaminant. So we chose to replace MTBE with ethanol. And by 1995, we started seeing a lot of ethanol in our fuels. Some properties of ethanol is it's from Octane point of view, it's pure ethanol is rated at 100 octane. It works better. The high octane number makes it work in higher compression engines. The higher the better. So actually your gasoline engines are a little on the lower end of where a typical gasoline engine is really a little on the lower end of where the ethanol ought to be burnt with regard to the compression ratio. The energy content in ethanol is just a little less than that of gasoline, but you do gain some energy efficiencies when you add ethanol to the mix because of the octane rating. Ethanol is hygroscopic in nature, meaning it likes to attract water, and we'll talk a little more detail about that later in this presentation. Gasoline, by comparison, is hydrophobic, meaning it does not like water at all. Volatility, it has some cooling properties, and we'll get to that. And then the last point I want to cover here under the property segment is it is a mild solvent, and there's some advantages and disadvantages to that also. Gasoline blends that contain ethanol, the most common, of course, is E10. It's a blend of 90% gasoline and 10% ethanol. It's rated for use in all engines, including the small engines. A fuel that's coming, and you find it in a few places, is E15. It's a blend of 85% gas and 15% ethanol. It is only allowed for vehicles 2001 and newer, road vehicles 2001 and newer only. It's not legal or recommended for use in a small engine. If you buy a brand new lawnmower at Home Depot or Menards or your favorite store, you're not supposed to and cannot legally put E15 into it, as well as any other higher blend of ethanol containing gasoline. E85, it's available at the filling station. It is only intended for flex fuel vehicles. It's not legal for use within your small non-road engine, and it will do damage. The little engines have some capacity for handling ethanol up to possibly 15, but if you get up to greater than 15, 20, 30% ethanol, you're going to do damage to your engines. Talk just a little bit about regular gas. In many states currently you can buy fuel that contains ethanol that it is not labeled on the pump, and in pretty much 70%, the literature I cite here, 70% of all gasoline contains ethanol. I would venture to say that it's probably much higher than that, and the labeling, whether there's ethanol in the fuel or not, depends upon your state. I know here in Kansas, and I believe the same is true in Nebraska, that there is no requirement to have a label of how much ethanol is in your fuel if it is below 10%. Now, even if it's if you're looking at the pump and it says E10, the seasonal variation, there is some seasonal variation in the amount of ethanol in that gallon of gas that you buy out of that pump, and that has to do with the way the fuel is intended to be utilized and to make sure that it is works at the temperatures that you may see at that point in time. Also, you have some local requirements for oxygenation. Again, this would be in your larger metropolitan areas. They may say, hey, we've got to keep our air clean, and all our fuel has to have a certain amount of oxygen in it. And ethanol is the oxygenate of choice, and so that can vary the amount of ethanol in your gasoline. Another thing to consider is price. Ethanol, depending upon the grain markets, depending upon availability of grain, depending upon the availability of oil and the current price of West Texas crude, your refiners and your blenders and your local filling station, they're looking to sell you gasoline or a fuel at the most reasonable price possible. And so they will vary the blend how much ethanol is in that blend, how much gasoline is in that blend to try to provide the lowest cost fuel that they can. So if you have an instance where ethanol is quite cheap and petrol gasoline is a little more expensive, you're going to be at that 10% level. The last several years where ethanol and corn prices were up there a little bit higher, probably a little farther away from that 10% level, just because it was, from the filling station's perspective, it was a little easier to provide a lower cost fuel with a little less ethanol. The other thing to think about gasoline is it changes over time. Environmental regulations come and go. Engine designs change. The refiners, as they make the fuel, they learn different things. They try different things. And so it changes. The point here is that the fuel you bought in the 50s, 60s, or 70s is much different than the fuel you buy today, and the fuel that you will buy in 10 years will be much different than the fuel that is out there today. The other thing about it is a very complex fuel. Ethanol has one molecular formula. As you can see here, there's a range of molecular formulas that make up gasoline. It also has a lot of additives to it, some detergents, anti-icers, corrosion inhibitors, and other things. All of these have impact on your fuel system. We'll talk about compatibility here in a little bit about ethanol and your fuel system in your little engine. But the other thing to realize is gasoline, as it comes out of the refinery, also can impact your engine. And it has some things in it that can be positive and negatives for your engine. So, in general, a late model small engine is probably E10 compatible. Manufacturers of these little engines, they were a little later to come to the table to make their engines compatible, but they realized that ethanol was going to be in the fuel, and they have made their engines compatible with fuel. Now, kind of like legacy engines that we talked about last August, some small engines stay around forever. I can think of a couple of small engines that I use somewhat regularly that have been around 15, 20, 30 years, and some of those older engines may have some incompatibility problems. And that is something that as parts degrade, you just go to the auto parts store and they will provide you with a material, a replacement part that is likely ethanol compatible. Now, again, ethanol is a solvent. It'll clean out deposits, and that is good, keeps your fuel system clean, but a lot of times those deposits, that dirt that maybe have collected in your fuel system, it has to go someplace, and your filters and maybe some of the orifices in the carburetor may get plugged with that debris, and it's just a matter of keeping it, recognizing that, and if you have some engine running problems, to go ahead and replace a filter, and then if it's bad enough, go ahead and clean out your carburetor. Another thing that ethanol may do is it may swell some natural rubbers. If you have that in your engine, and the engine may have ran fine on regular gasoline, but now you have a fuel that has some ethanol in it, those rubbers may swell a little bit, and that can be causing some problems. Ethanol can also degrade some alloys of metal. That's something that doesn't show up for for time. It may take a few years for that to actually show up, and you may have some leaks or things that just don't work. Fiberglass is also a problem for ethanol, or ethanol is a problem for fiberglass. If you have a fiberglass tank and you're adding a fuel containing ethanol in that, it will tend to try to dissolve that tank, and the first thing that happens is you get the sludge in the bottom of the tank that will cause you some problems if it gets into your fuel system. Now, talking about small engines and their seasonal usage, the thing to remember in some small engines, some ethanol sometimes gets blamed for some problems with small engines that are not really having anything to do with that does not have anything to do with ethanol. It has to do with the nature of the small engine. Engines that are not started regularly are more likely to have starting and running problems. If you've got an engine that you only start once a year, it's likely to have some problems regardless of what the fuel is. The other thing is if you have an engine that sets a long time, you're more likely to have water collect in the fuel system, and that really doesn't have anything to do with whether there's ethanol in the fuel or not. And when you have water in your fuels, that can cause some starting problems. You can have some engine performance problems, meaning that the engine just doesn't run right, and then you can rust through your fuel system. Also with that water, and you have a metal fuel system, it can rust it through. Storage is the key, both of the engine and the fuel, and we'll come to discussing that here in a little bit. So we'll talk about the small engines and storing away, and this would be something that we should have been thinking about last fall, and if you're like me, you don't really think about it till this spring. But there's a couple of ways when you put your engine away in the fall of the year that you ought to consider storing it. One is to have the tank of your small engine empty, drain the tank, start it, and run it to get all the fuel out of the system. Let it run itself empty. Place your cap on your fuel tank on your engine, and then store it in a small dry place, and preferably something that doesn't have a lot of dirt in it, so that you aren't getting dirt into your system. The risk to this is if you have a very, very humid day that you put your engine away, and then the temperature of that area where you're storing your small engine away starts to drop. If there's a lot of humidity inside that engine, in that fuel tank, then the water can collect and then collect in the bottom of the tank and be there. And then when you add fuel into your tank, then in the spring of the year, you're going to have a whole bunch of water there that may be the first thing that goes into your carburetor when you try to start your engine. That's a risk that you have in storing an empty tank. The other alternative is to store your tank full. Add a fuel stabilizer if you choose to do this. Put your cap on your tank tightly. Again, store the engine in a dry place. Some of the risks to this method of storing the fuel or the engine away is you can have some gasoline that could go stale over the winter. Also, a risk always with ethanol fuels is some separation, and we'll talk a little bit more about that in a bit. Again, if you're adding a fuel stabilizer to your tank, that can mitigate any problems that you have down here of gasoline going stale or the ethanol separating out. The other side of this is to look at your fuel storage containers. One of the discussions or thoughts with regard to ethanol is phase separation. If you have water or an ethanol-containing fuel and you have water present, you can sometimes get some separation, but it usually takes quite a bit of water. And if you're, again, following a good practice of keeping your fuel storage container tightly capped off, the likelihood of getting enough water in there to cause phase separation is pretty low. Ethanol is hygroscopic, meaning that it does attract water, and this can be considered as a negative, and a lot of people do consider it as a negative, but it has a tremendous positive side to it in that you can absorb a lot of some small amounts of water in fuel tanks. So if you think about this, you've got your small engine, you put it away on a very humid day in October, and now you open it up and you're going to run it this spring, and you've just bought some fresh fuel that contains some ethanol in it. What's going to happen is when you dump it into the tank, there may be a little bit of water laying there in the bottom of that tank. What the ethanol in the fuel is going to do is it's going to absorb that water into your fuel system or into the fuel, and then when you run your engine, it's just going to pass that water through the engine without any harm. Gasoline, on the other hand, is hydrophobic. It will not mix with the water. So if you had a pure gas and you dump it into the same engine, that water will just stay there at the bottom of the tank, and it does have the potential of being drawn into the fuel system and going into your combustion chamber of your small engine as pure water, and then you have the risk of some damage to your engine or poor running of your engine as a result of that water going directly into your fuel system. So, fuel storage for a small engine is important. One of the first things you should do when you buy all your fuel is consider buying a fuel stabilizer and adding it to the fuel. That way, if you come to the end of the season and you've got a half a tank of fuel there, then you have it ready for storage. Store your fuel in a cool, dry place. Use an approved container and keep the tank sealed to keep moisture out. Another key thing is to shake your container before adding fuel to your tank. If you had a little water collect in the bottom, by doing that, it disperses the water throughout the container. The reason why this is important to do it is that if you have this an amount of water in the bottom of your fuel storage container and you're pouring it without shaking, you do run the risk of running pure water, an amount of pure water into your little engine tank, and by shaking it, you disperse it, and the likelihood of running a large amount of relatively large amount of pure water into your engine tank is reduced considerably. You should not keep any gasoline fuel longer than 180 days. There's a lot of numbers out there. That's kind of my personal rule of thumb, is don't keep it over 6 months for two reasons. One, the fuel can go stale, but two, your fuel changes seasonally. The fuel that you buy in August is different than the fuel you buy in December, and if you've got a fuel that you bought in August and you're trying to run it in January and February, it's not going to run as well as the stuff you buy there in December. Ethanol fuels, the claim is, should only be stored about 90 days. Again, the phase separation is a little bit of a concern there because of that. Generally speaking, it is recommended that you only purchase enough fuel to use within 30 days, though if you go back to this first point of adding a fuel stabilizer, it reduces the problems of either the 180 or the 90-day storage. But let's face it, you really shouldn't be buying a year's supply of fuel at one shot. You need to realize how much fuel you're going to use in a season, or the life or the seasonal usage time of your engine, and just buy enough fuel that you utilize that, and you're not ending up storing a whole bunch of fuel over winter or over summer, if in the case of a snowblower. Another thing to consider with small engines compared to your road engines, your automotive engines, is they are very, very simple. They have no computer controls. The small engines tend to have a fixed air-fuel ratio. They tend to use an engine with a carburetor. They're task, speed, and power specific. They're very cheap, and they have a very short duty cycle. If you look and compare this road engine versus a small engine here, they're night and day difference. This is a fuel-injected engine. This is a carburetor. This has a computer control system with sensors to sense the exhaust. This has an exhaust pipe, period. They're a lot different, and that feeds into our next topic of how they are operated. The power and speed is usually set by the manufacturer. In the case of this pressure washer here, you are going to run the engine at an operating speed, and that's it. The intention is not to idle and operate or run half throttle or three-quarters throttle. You're going to open that throttle up to full power and operate it at that speed and then shut it off. With that, the manufacturer also, as they are designing the engine for this application, they are setting the air-fuel ratio. They set it to make the engine run at a certain temperature and provide a certain amount of power output. They also realize that the fuel can have anywhere between no ethanol to 10% ethanol, and so they are taking that into account as they've designed the engine. Anything outside of these ranges that you end up using this engine can potentially lead to problems. If you try to run higher speeds or lower speeds in this application, you're going to have problems. If you change your air-fuel ratio, you can potentially have problems. Change your power output, you can potentially have problems. If you run anything higher than a 10% blend of ethanol in the engine, you will probably have problems. And we'll get into that in a little more detail shortly. Talk briefly about the combustion basics of the air-fuel ratio. I think I talked about it earlier, so I won't go into the same discussion to talk about it. But this would be this is kind of a schematic here of what happens when you are combusting fuel in an engine. You're adding fuel and air. You add a spark, and the results of combustion are water, CO2, some engine energy, and then some other things that come out. For complete combustion of ethanol, if you take 9 pounds of air and 1 pound of fuel, you can get complete combustion of ethanol. Gasoline has a combustion ratio, air-fuel ratio of 14.11. Again, 14.11 pounds of air to 1 pound of fuel for complete combustion. Variations off of these air-fuel ratios, if you have a little more air and a little less fuel, that's a lean mixture. If you have a little more fuel and a little less air, that's called a rich mixture. The engine manufacturers rarely run the engines or design the engines to run at that ideal combustion ratio, like of gasoline of 14.11. Even if they know that they're going to run an engine on pure gasoline, they will set that engine to run rich. They do that because, one, they can get more power out of the engine, and two, they can get the engine to run a little cooler. By adding a little extra fuel into the combustion chamber, they can actually cool down the combustion temperatures of the gasoline. By retarding the amount of oxygen available to combustion, they can keep that temperature down. If you add more oxygen to the chamber, then you can heat the temperature of combustion up even higher than the normal combustion temperature of the fuel. And we'll talk shortly a bit more about that shortly. So, when you add ethanol into the mix, what that does is that tends to lean the combustion mixture. So, for example, if you are running at that 14.11 air-fuel ratio and you add ethanol to the mixture, what in essence happens is you lean or make the mixture a little bit leaner. This happens because the ethanol molecule contains a little bit of oxygen, and that is just like adding more air to your fuel mix. Some symptoms of enleadment is a little bit of power loss, engine heating. Again, we talked about that just briefly, is that if you add more oxygen to the mix, you can increase the temperature. If you take more oxygen away from the mix, you can decrease the temperature of combustion. And by adding the ethanol, you're adding more oxygen, so you're enleading the mixture, and so you have the potential of heating the engine up a little bit. The other thing that happens, particularly in small engines, is this does change the idle speed. Your idle speed can actually creep up a little bit by enleaning the fuel-air mixture. Again, the engines are designed to run at a specific air-fuel mixture, and by adding a little bit of oxygen in there, you enlean it, and that can change the operating characteristics and cause it to run a little faster, and that can have some impact on your line trimmers and your chainsaws. So, what's the impact on the line trimmers and chainsaws? Well, they have the centrifugal clutches. At idle, a centrifugal clutch is not engaged as you, like on a typical chainsaw or a string trimmer. There's a trigger of some sort that you pull back to increase your throttle and increase the speed of the engine. As the engine reaches a certain speed, the centrifugal clutch engages and everything starts moving. The chain starts moving in the chainsaw, the line starts swinging in the line trimmer. Well, if you have enleaned your mixture and that increases your idle speed, it can increase it up enough that now the idle speed is high enough that the centrifugal clutch engages. And that can be a sign that you have maybe too much ethanol in your mix. Now, if you're having this problem, it's not a major problem in the fact that you can no longer use your trimmer or your chainsaw. It just means that what you need to do is recognize that yes, my 15 to 20-year-old chainsaw is now using a little bit of fuels containing ethanol, and because of that, the idle speed is higher. I need to go in and change my idle speed by adjusting the fuel mix on the carburetor. If you don't feel qualified to do it yourself, take it to a small mechanic and oh my. Okay, looks like we're back. But anyway, if you have an older engine that the idle speed is too high on it, and you're having a centrifugal clutch engagement at the centrifugal clutch engagement problem, you can go in and change the idle, the fuel mixture, and that can change your idle speed, and that can solve the problem with the unintended clutch engagement. Most of your new trimmers and saws that can accommodate E10, the manufacturers recognize there's going to be fuel ethanol in the mix. They've taken that into consideration and made the machines operate correctly on up to E10. Where as we go forward and E15 becomes greater, has a greater availability, this could be a key that you've gotten the wrong fuel when you went to the filling station. Is that if you've been using regular gas and all of a sudden now your string trimmer and your chainsaw will constantly engage their clutches, it could be the fact that you just went to the wrong pump and you put E15 in your little storage container instead of E10, and you really need to go back and drain that fuel and get some different fuel for your little engine. A little bit of misfueling, the engines probably will tolerate it pretty well, but if you are misfueling it regularly, you're going to eventually do damage to the engine. Not only that, you're also breaking a law because your small engine is only rated for E10 by law. So the next thing we want to talk about is fuel system contamination. I have to apologize with the system seems to be jumping around here. Hopefully we can get through that without it totally collapsing. The fuel system contamination, again, we came back to one of the characteristics of your small engines. They're running in a dirty environment, or they're running sporadically, and meaning that they're used seasonally, and they're in storage a lot of time, and as a result, there's dirt in the fuel system, either from contamination from the operating environment or because of the fuel's just set there and it's dried out and you get some varnishes or sludges inside your tank. Ethanol, if you dump it into your fuel system for the first time, it could go out and clean all that sludge out of your system, and that sludge could go someplace, and one of the first places it'll wind up is in your fuel filter, or maybe in some of the ports in your carburetor. The advantage to having ethanol in your fuel, and it's been there for some time, is your fuel systems are probably pretty clean already. It's keeping those deposits from forming. Any of the water that's in the fuel system is being absorbed and taken away because of the ethanol there, and it's keeping your engine clean. So likely as not, you're probably not seeing a lot of problems due to ethanol, because it is keeping your fuel system clean. You're probably not having a filter problem, and your carburetor's ports are probably quite clean because you do already have ethanol in your fuel system, most likely. Some other considerations. Ethanol has some vaporization considerations that can, in the summertime, pressurize your fuel system because of the way it vaporizes, and in doing so, it can make the system think that there's no need to supply fuel, and so you can't start your lawnmower after you stop to take a breather after mowing the backyard and move it before you move to the front yard. All you can do is let the system cool. Cold start in the wintertime, if you have, say, bought some fuel for your lawnmower and you kept it around for your snowblower. You bought the fuel in August and you've kept it for your snowblower to blow off that first blizzard in December. You may have some trouble with the fuel starting because the vaporization temperature of the fuel in the summer, it's changed relative to that in the winter. Your winter fuels are a little bit more volatile, and so if you're carrying over that summer fuel, you could have some problems there. Again, you're likely to have a little more ethanol in the summer than in the winter, and it's just because of this the winter engine starting. Some emissions in the environment. One of the things we talked about, the engines running rich regularly, and that from an emissions point of view in the small engines is a real negative. Your small engines are considered one of the worst polluters of hydrocarbon emissions, carbon monoxide, and NOx. Adding ethanol to the mix reduces all of these, so your emissions and your environment is improved by having ethanol in your fuel. The other thing is ethanol replaced the oxygenate MTBE, which was considered to be a kind of a nasty groundwater contaminant, and so ethanol, from an environmental point of view, from combustion, is a real positive. So coming down to it, so the advantages of ethanol or the system cleaning: you get an octane boost, some water control, your emissions. There are some cooling aspects to ethanol in how it's fed into the engine. It will clean up your charge air into your combustion chamber, and that can reduce your operating temperatures with the proper air-fuel ratio. So points I'd like you to remember from today is that ethanol is a quality fuel, and it's going to be around here for many days to come. But gasoline, too, is continues to evolve and change, and that you can use an E10 fuel in a small engine without any problem, but don't use anything greater than that in your small engines. Store your engines and fuels properly. Pay attention to that. That's probably the biggest thing that you need to be aware of, that if you do the storage of the engines and the fuels, you're going to save yourself a lot of problems with starting and operation of your small engine. And then also and the last point here to remember is that your ethanol can impact your engine idle and centrifugal clutch engagement. And so if you've been having some problems with your line trimmer running all the time, it probably has something to do with the idle adjustment. You need to have the mixture changed on your small engine. Some more information if you want to read about it. There's a publication from K-State on small engines that is a good discussion and is actually the basis for this webinar. It was something that I've written about 18 months ago and have used it extensively in preparing this webinar. If you really want to get into the understanding gasoline and ethanol containing gasolines, I highly recommend this publication, Changes in Gasoline 4. It is a technician's guide, and so it's well worth your reading time if you're really interested in this topic. The other thing is the effects of intermediate ethanol blends on legacy vehicles and small non-road engines by Oak Ridge National Labs. It's a quite long report. I think it's 185, 200 pages. Fairly technical, but if you're really interested in this topic, I highly recommend it. And as you can imagine, I have drawn heavily on it from this publication as I've developed these two webinars.
This webinar has been brought to you by the Farm Energy Community of Practice and the University of Nebraska-Lincoln Extension. For more information, go to farmenergymedia.extension.org.